Go guys, this question's getting to everyone because it is a nasty piece of work. So we start off it's a callback to question 1, I think, but there is no relevant information from question 1, so let's ignore this first sentence. Blah 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 blah. If Sam places his pen in the corner of his property against 2 existing fences, so these are already here, he might be able to build a pen each for the pigs and 1 for his chickens. If he just uses his original 48 meters of fencing, calculate the dimensions of the total enclosure which result in a maximum total area, and calculate this area. Okay, now, first problem with this question is it's impossible. There are too many unknowns. The whole point in optimization, optimization with differentiation, the whole point is you need one variable. You're going to have probably 2 equations, so it's very much like substitution. You're going to have 2 equations and 2 variables usually, and you have to whittle it down to 1 equation with 1 variable. So you want 1 equation and you want 1 variable. The problem with this question is this length, the height we'll call it, or the length, whatever, the height here is one of your variables, right? And then these lengths here, which are going to be equal, are going to be another variable. And then the flippin' picture makes it seem like this is its own variable. Now that's dumb. You're going to have 3 variables, and then you're going to make an equation out of the length of the fencing, and then you're going to make an area equation. So you're going to have 2 equations, and you're going to have 3 variables, or 3 unknowns. Right? This doesn't work in maths. So the whole thing about this is the question's impossible. So we have to break it down to 2 variables. And the best way to do that is to make an assumption. So we're going to need to assume that the chickens get the same amount of space as the pigs, which is fair enough. In fact, in many cultures, you would get rid of the pigs entirely. Right? So what we're going to do is we're going to assume that the assumed chickens need same area as pigs. It's an easy assumption to add in, and it fixes the dumb problem, right? It means that this length here is going to be equal to these lengths here, so that means this is going to be 1 variable, and then this is going to be another variable. Another problem that I see people doing with this is they forget the fact that this is already fenced. They've done it in bold to show you that you don't need to worry about this. So let's have a go at the problem then. Okay, so what we have is we've got our pen. We're adding in this fence here, this fence here, this fence here, and this fence here. And we've got 48 meters to do that. 48 meters of some rolled up, I don't know, I've actually done fencing before. I should know how to draw some sort of rolled up fence. Right? We've got 48 meters of this rolled up fence. And we need to put it here, 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 and here. Okay, what we're going to need to do is we're going to need to put in some variables. So, I mean, let's just use x and y. X, and this is the same length here, x. This is the same length here, x. We need to put a bit of fence here, bit of fence here, bit of fence here. Right? Now here, this we're going to assume is length y. This we will also make it y. And this will also be y, because we had to make this assumption that chickens need the same area as pigs. Right? So now each section is going to be x by y in area. Now, we're trying to maximize the area. So what will the area be? So let's make our 2 equations. We're going to say area, and we know that the area of this overall thing, this is what we're trying to maximize. The area of it is going to be the length times the height. I often write it out like this: length times height. Right? This being our length, this being our height. So what is that going to be? Area is going to be, length is 1, 2, 3 y's, and it's 3 y's multiplied by the height, which is an x. 3y times x. The problem is we can't optimize this right now because we have two variables. So we need to introduce our other equation, and it's to do with this fencing here. So I'm going to introduce the other equation over here. Now, how much fencing do we need? We need y plus y plus y. So it's going to be 3y. And then we're going to need x plus x plus x plus 3x. And that overall has to add up to being 48 meters in total. I might put a little m there. Why not? Now, what we need to do is we have two equations and two unknowns. We need to join them together into the equation that we're optimizing, which is area. This is the one that we're trying to optimize. So we're going to have to rearrange this to get rid of one of these variables. I'm going to get rid of y because x is, you know, what we usually deal with. So let's get rid of y. The best way to get rid of y is make this equation all about y. So I'm going to move the equal sign over. Sorry about it, guys. So I'm going to remove 3x from both sides. So it's going to be 3y equals 48 minus 3x. Right, I just minus 3x off both sides. Then I need to get rid of this 3, so y is by itself. Ooh, actually, look at this. 3y is equal to that. And we already have a 3y over there. So let's just substitute 3y for 3y. Even easier. Okay, so now it's going to be area equals, and we're going to replace our 3y with this. That's the whole point. We want to make it so there's only one variable. So we'll replace our 3y with 48 minus 3x. 48 minus 3x, because these are equal to each other, and multiplied by x. Whoopsies, that looks too much like a plus. Now, our area equation is now only in regard to x. Now we can start doing calculus on it. And in fact, I'm going to write area in regard to x. That's what a function is, right? Normally we do the function in regard to x. But now our function is finding area, and it's in regard to x. Perfect. A of x. Let's expand this. 48x minus 3x squared. Perfect. We now have a way to find the total area, and it looks like it's a negative parabola. Beautiful. We can optimize a negative parabola and find a local maximum. Right? So we're going to be able to find that maximum by differentiating, and we'll end up seeing that the derivative will show us where our maximum on the original function is when the derivative is equal to 0. Perfect. Just what we wanted to do. So let's do it. A dash of x equals 48, differentiate 48x, minus, and then differentiate this, 6x squared. Now, all we need to do is set that equal to 0. When is that equal to 0? Well, 0 equals 48 minus 6x squared. You could just chuck this into your calculator, do a little bit of rearranging, you're in quadratic form, and then chuck it into your solver in the calculator. Or we could do some fancy pants math. Let's do some fancy pants maths. I'm going to add 6x squared to both sides. I'm going to divide both sides by 6. 6 times 8 is 48, I'm pretty sure. And then therefore, x equals the positive... Ooh, wait, what have I done wrong here? Oh, crap. Dang it! Okay, I differentiated wrong. I forgot to remove 1 from the power. Let's just fix it up. All good. All good. All good. All good. Boom. X equals 8. Dang it. Oh, that's good to see that there are mistakes. Notice that if I do super fancy tidy writing, it's really easy for me to go through and do scribbles and fix up my error. Now, this happened when x was equal to 8, which means that the maximum occurs on our upside down parabola. The maximum area happens when x is equal to 8. So to finish off the problem, we need to substitute it back into this equation. So A of 8 is equal to 48 times 8, oh, I'm going to have to start doing that in my head, minus 3/8 squared. Okay, 48 times 8. 8 times 8 is 64. 4 times 8 is 160. 320. 384. I did this wrong when I was explaining it to another student. 64 times 3, 180 plus 4 times 3, 192. This is where I think I went wrong here. 384 minus 200 is 184, and then we'll add on 8. 192 meters squared is our area. Let's just double check that that's what the question they're asking. Blah, blah, blah. Calculate the dimensions of the total enclosure which result in a maximum total area, and can calculate this area. We don't quite have the dimensions because we only know the x aspect. We need to find the y aspect. So let's just do that. Where is our relationship to find y? Here it is. So let's just quickly do that. 3y equals 48 minus 3 times 8. I need to keep this separate. 48 minus 24 equals 3y equals 24, y equals 8. So the dimensions, which is also asked for in the question, is 3y 24. 24 meters times 8 meters. Those are the dimensions. That is the maximized area of our chicken and pig pen, when we assume that chickens need the same area as pigs.